Okay, so the possible rational zeros would be all of your factors of your constant 12 divided by all of the factors of your leading coefficient of 2. So if you list them all out, factors of 12 would be 1, 2, 3, 4, 6, and 12. Factors of 2, thankfully just 1 and 2. And then do all of your possible combinations. They could be both positive and negative. So if I divide everything by 1, that's a factor of 12. I just get the originals, positive and negative. If I divide everything that was a factor of 12 by 2, a lot of them are repeats, but I'll end up with positive and negative 1/2 and positive and negative 3/2 that I didn't have before. So that's kind of what we did yesterday. There's all your rational zeros. In terms of new stuff, we're going to be looking at what's called the multiplicity of a polynomial, or multiplicity of a zero, sorry. It's basically, if you have your polynomial in factored form, the number of times the factor appears in your polynomial. So say you've got this polynomial. You have two zeros. If you set it equal to 0, x equals negative 1/2 and x equals 4 are both zeros of that polynomial. The factor that you got your 0 of negative 1/2 from was raised to the second power, which means we can say that that 0, x equals negative 1/2, has a multiplicity of 2. So however many times your factor appears in your polynomial, that's its multiplicity of its 0. The factor of x minus 4 was just in there once, so it's just a 0 with a multiplicity of 1. Okay, so looking at this polynomial, we're going to find all of the zeros and state their multiplicities. So to find all the zeros, let's first set it equal to 0, because we're looking for what x values give us 0 as our output. Just a little rewriting. Okay, setting each factor equal to 0, and then we'll solve. That last factor is pretty messy. First one, divide by 5, just get a 0 of 0. Second one, add 3, take the square root. Don't forget that that gives you positive and negative square root 3. Last one, have to add 1 and subtract square root 2. So those are your zeros right there. There's 4 different zeros because positive and negative square root 3 are different zeros. If we look at the multiplicities of each one, go back and look at your factors that they came from. So x equals 0 came from your factor of 5x. That was just in there one time, so that's a multiplicity of 1. Your factors, or your zeros of positive and negative square root 3 came from a factor that was raised to the third power, so they each are going to have a multiplicity of 3. And our last 0, fun one with the square root, that factor was to the second power. It's in our polynomial twice, so that means it's going to have a multiplicity of 2. Okay, we're going to turn it around and we're going to write a polynomial that meets some requirements and has some certain zeros. It's supposed to have a degree of 3 with zeros of negative 1, 2, and 4. And when we plug in 1, we're supposed to get 3 as our output. Let's start with the zeros part. If we know those are our zeros, it's going to have factors of x plus 1, x minus 2, and x minus 4. It's degree 3, so those should just be all to the first power. Otherwise, our polynomial, if we were to multiply it together, would be higher than degree 3. So just multiplicity of 1 on each of those. Now when I plug in an x value of 1, I'm supposed to get 3 out. I'm not sure if that happens unless I possibly have some leading coefficient multiplied times all of my factors to ensure that I'm going to get 3 as a result. So let's solve and see if we need a coefficient there other than 1. Plug in 1 for all my x values. I'm supposed to get 3 out. 1 plus 1 would get me 2. 1 minus 2 is -1. 1 minus 4 would be -3. Multiply them together to solve for a. And you'd end up with a equals 1/2. So you'd have to have a coefficient of 1/2 in there for a times all of your factors. Otherwise, when you plug in 1 for all your x values, you don't get 3, and we're supposed to. So I'm just going to erase, and that would be your polynomial that has those zeros and gives you f of 1 equal to 3. Now in your textbook, I think they're going to multiply all of that back together and put it all out in standard form, so like 1/2 x cubed plus whatever other terms you get, but I'm okay with you leaving it in factored form. Let's do one where you have some zeros that are complex numbers. So if 2 plus I is a 0, don't forget that that means that 2 minus I, your conjugate, is also going to have to be a 0. So whenever you're writing this polynomial out, well, the only thing we really have requirements-wise is those zeros. So let's just do our factors. If 2 plus I is a 0, then x minus the quantity of 2 plus I is a factor. And then for our conjugate, x minus the quantity of 2 minus I is also a factor. Now, when it was all real numbers, I was okay with it being in factored form, but this is really messy, and if you multiply it back, it'll get a lot nicer. So if you have complex numbers, go ahead and actually multiply those back together so that you're only going to end up with real number coefficients. It's going to be a little bit messy, but please do. So let's multiply our complex number ones together first. That's going to be a little bit easier. I'm going to go ahead and distribute my negative into my 2 plus I and 2 minus I, and then multiply them. So that'll be x minus 2 minus I and x minus 2 plus I. So it is pretty messy when you multiply them together. Just a lot of distributive property. So I'm going to multiply my x times everything. And then I'll multiply my -2 times everything. Just be really careful whenever you do this. And then I'll multiply my -I times all of those. Luckily, there's some like terms. X squared's the only quadratic. -2x, -2x gets you -4x. I've got a positive and negative ix that'll subtract off to 0. Negative I squared is going to be opposite of -1, so positive 1 that I can add to my 4 to get 5. And then -2i and positive 2i subtract off to 0. So it ends up a lot nicer with only real number coefficients in there. And then we'll go ahead and multiply it all the way together and take that x minus 3 and multiply it times our x squared minus 4x plus 5. And we're going to get some like terms that we can combine. I sort of like to line them up. You end up with x cubed minus 7x squared plus 17x minus 15. So that's your polynomial. Good luck on your homework assignment. If you have one like that, please multiply it back together so that you have a nicer result than all those complex zeros.